Alhamdulillah. Alhamdulillah wa salatu wa salam ala Rasulullah Muhammad bin Abdullah wa ala alihi wa sahabihi wa mawala wa ba'd. Welcome to this our channel, Source Academic Online Class. Today we are going to be seeing something on nomenclature of ether. What do we mean by nomenclature of ether? Let's quickly recall that whenever you hear nomenclature, even in biology, we mean naming. How do we assign name to ether? When we see an organic structure binding with ether, how do we name that organic structure? As far as ether is present in that organic structure, these are what we want to look into. Am I communicating? And note, when we are doing this, firstly, let's know what is even ether. Ether, I won't explain much on this ether. I just want to go straight to the point. But let me quickly see. Whenever you see O, the word O here means oxygen. When you see oxygen, and when you see a substituent or a branch here or here, branches are attached to this oxygen. I mean, like when we see a key group, maybe we still have another key group. And we all know that a key group are the ethyl, propyl, butyl, hexyl, and so on. So the same thing applicable to this. What is at the middle here? Oxygen. This is what we call ether. Whereby the substituent, I mean the branch that is not part of ether, is this alkyl, these two alkyl group attached to it. So they can ask you to name this. So how do we name this? That is what we want to do. Then not only alkyl can be attached to ether. I've told you that how do we denote ether? Oxygen. This O mean ether. Not only alkyl group, another substituent or branches can be attached to this ether. Like I can have, this is from aliphatic hydrocarbon. I can have it to be, I mean straight line hydrocarbon, like propyl. So when I said not only aliphatic, we can still have an aromatic compound attaching to the what? To this ether. Like, what do I mean by aromatic compound? Like AR. AR mean aromatic. The here too can be AR, aromatic. From what? Ring family. Our cyclic organic compound. Example is this. Are we together? So example is this. This is the best. This best explain this. What do we have here? We have benzene. This is benzene. This is phenyl. This is phenyl. When they are attached to, what are they attaching to? Ether. This is their what? This is their let me say molecular formula. Then this is their structural formula. So here is the example that best explains this molecular formula is this one. You can see straight. So now this is the molecular formula of when we have ether binding with another organic compound. So this is the molecular formula. Why this is the structural representation, which is the structural formula. When I say structure, you can see the drawing here. When I say molecular, there is not anything like down here. But we have ether, then we have the denotation of what is denoting that there is present of what aromatic compound there, which is AR. The same thing applicable to this. This is the molecular formula. Why this explain the what structural formula of what this is. Hope I'm communicating. So since we have gotten this one, that this is the ether, I've explained it, and we want to name. If you are having this, how do we name this? How do we name this? How do we name this? So how do we name ether? That's what I'm doing today. How do we name ether? Let me firstly start with this one. Are we together? So you can see this one now. We have, if I want to represent this molecularly, what do I? This one, note that we have how many carbon here? We have one carbon here, we have another carbon here, we have another carbon here. Making how many carbon? 3 carbon. When we have 3 carbon, as far as organic chemistry is concerned, it is what? 3 carbon. It is what? It is but we don't know if it is going to be propane or propene or propine or propanol. Are we together? But as far as this is concerned, we have single bond inside here. What do we mean by single bond? There is not anything like this. It is not double bonded molecule. All are single. From this carbon to this carbon, all are single. They are bound in a single manner. So that means this particular one, let's firstly deal with that, is from what? Alkane, a single bonded organic compound. Are we together? A single bonded what? Organic what? Compound. Which this one is what? When we have 3C, it is pro. And since this all these things are single bonded what? The carbon to carbon, there is no any double bond there. Carbon to this carbon, there is no, we call it propane. That means it's fall on propane family. So we call this one, but it is arranged in what? We have what we know as alicyclic what? Alicyclic hydrocarbon. Alicyclic hydrocarbon. When I say alicyclic hydrocarbon, I mean those hydrocarbons that they behave, they behave like aliphatic hydrocarbon, but they are not aromatic. Meaning, when I say alicyclic, meaning they will be, their structure will be in a cyclic form, like an aromatic something like this, like aromatic organic structure like this. But they are not aromatic in nature. They are aliphatic in nature, meaning they are straight chain organic compound in nature. Well, I can decide to write this back in the form of this. This one, what I'm explaining is that this can be C to C to C, then to O, then bonding to this, bonding to this. These and these are almost the same thing. But what happened? How many carbon are we having here? 3. But they exist in what form? In a straight form. This one is still the same thing as writing it like this. Are we? This is still the same thing as this. But this carbon exists in what? In aliphatic arrangement, in a straight arrangement. So this is normal propane. This is abnormal propane, like zigzag arrangement. But it's still the same thing as this. Whatever the name that assigns to this goes to this one as well. The same thing. It's just that the way they were structured is different. But compared to this one too is 3 carbon. But they are arranged in what? In a cyclic form, like a circle form. It is different from this arrangement and this arrangement. So when you see something cyclic like this, but also they are stretching. They are stretching carbon to this, it is like this. But this carbon, if I join it like this, they become something circle. Is that not? That is why they call them cyclic. There is attribute of cyclic in them. But alicyclic, meaning they are not a ring organic structure. They are also aliphatic organic compound. But they just draw the structure in terms of being an aromatic what? Arrangement. But they are not aromatic. Meaning they are not cyclic. They just exist in cyclic form, but they are not cyclic. That's why they put alicyclic. If it is a cyclic structure, this is the cyclic structure. This is a cyclic structure. This is benzene, cyclic structure. But if you have something like this, this particular something, carbon here, carbon here, carbon here, carbon here, carbon here, carbon here. Carbon to this carbon, what is bonding them? One single bond is bonding this to this. How together? We call this is different from this one. We call it cyclic. Also, it resembles this shape. But this 0 that is here, meaning there is one bond here. That means 1, 2 that join these 2 carbon. There is bond here. Are we together? That join these 2 carbon. But compared to that is all this is mean. Compared to there is nothing joining. That means all I can do like this. All are in a straight what? In a straight pattern. Are we together? Only single bond. We call this cyclic but alicyclic, meaning they are not double bonded organic structure. That is why they call it alicyclic hydrocarbon. Hope I'm communicating. So that is that under that. So example of alicyclic hydrocarbon are, we have, let's start from this one. We have cyclopropane, we have cyclohexane, we have butane, we have cyclopentane, and so on and so forth. These are the cyclo, but they fall under alicyclic because they are single bonded organic structure. So that means this, how many carbon are we having? 1, 2, 3. 3 carbon. But they are in form of cyclic pattern. The arrangement is in form of cyclic. So we call it 3 carbon is pro. But due to their cyclic in nature, we call them cyclopro. And you know it's a single word, cyclopropane, that should be. But you know, this particular propane is C3H8. When you deduct one hydrogen from it, it becomes C3H7. That which this one becomes propyl alkyl group. But what type of propyl? You know, normal propyl is like this. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen. How many hydrogen? 7. 1, 2, 3, 4, 5, 6, 7. There's one hydrogen that is what? That is being removed here. So are we together? Then it's being replaced with oxygen. That's what this structure means. But this one is in a straight pattern. This is normal propane. But when I structure it in this particular, in terms of this, it becomes cyclo. That means it's in a cyclic form. Are we? But also it has the carbon to carbon also has single bond. But they are what? In a structural, in a cyclic form. Are we together? That's that under that. So now, due to how many hydrogen that are supposed to be there, it should be 8, but they have removed one, replace it with this ether. That means this one is propyl. Then since the arrangement is cyclic in nature, we call it cyclopropyl. Are we together? It's supposed to be cyclopropane. I said they have removed one hydrogen. The hydrogen should be 8, but they remove one, making C3H7. This is C3. Then the H is now 7, not 8. The remaining H, that is what is replacing this oxygen, which is the ether. Are we? So that means we don't call it propane, we call it what? Propyl. But in what structure? In what structure? It is arranged like this, in cyclic pattern. That's why I say cyclopropyl. Am I communicating? Now note that I've answered this one. This is ether. Then this one, we all know that this is benzene. Are we together? Once this one attached to it, that means, you know, so benzene is C6H6. That is the molecular formula for what? Benzene. That means one is being removed. Once you see this stroke like this, that means one hydrogen is also being removed here. The same thing applicable to what they did here. One hydrogen that is being removed from this is benzene. Then when they remove one hydrogen, it becomes C6H5. This is phenyl or phenyl, anyhow you want to call it. Phenyl. This is benzene. When they remove one hydrogen, it becomes vinyl. So that means this is vinyl when it's having. This is what I'm saying. This is benzene. Once they signify this one, meaning they have removed one hydrogen that is making it to be 6, then it's reduced to what? It has been reduced to C6H5. Are we together? Hope I'm communicating. So now it is attached to oxygen, which is this. They remove one hydrogen from here, C3H8 before. They remove one, making C3H7, which is propyl. Now this is phenyl. Are we together? Then this oxygen means what? Ether. Now let's try to name them. I'll break them. I'll break this one. I'll break this one. Now we have 2 ways of naming. We have how many ways of naming? You can name this in 2 ways. Please and please, for those preparing for the A-level student, please try and listen. We have 2 ways of what? Naming this. You can either use a method known as substitutive or substitutive method. Are we together? Substitutive what? Method. Substitutive method. And you can also use a what? A functional method. What do we mean by, and I will use the both. What do we mean by substitutive method or functional method? Substitutive method means the act of assigning name to ether, whereby how many substituents am I having? This is the ether. But how many substituents am I having? Meaning how many things that is joining hand to come and make this oxygen. How many things are? That's what we mean by substituent in chemistry, as far as organic, or branches, you can call it like that. This is ether. What is joining with ether? This one, cyclopropene. What is joining with ether? Phenyl. We call them substituents or branches. Are we together? So when they said use substitutive method to name this, all you need to do is very simple. If they ask you, you firstly identify the substituent that is present here. How many substituents do I say is present here? 2, which is the cyclopropene. So I've started naming this. We have 2 substituents. Substituent. I have 2 substituents or 2 branches. What and what? I have cyclopropene, and I also have what? Phenyl. I've explained that. All together, these are the 2 substituents. All you need to do when you are using substitutive method to assign name to this organic structure, you pick one